Alright, now let's look at the basic workflow of Stardust. First, you create an emitter and assign a clock to it. Then you add initializers to the emitter and add some actions to the emitter. Next, you create a renderer and you add the emitter to the renderer. Lastly, you repeatedly call the main loop, which is the step method of the emitter object, and the renderer will handle the visualization automatically. Okay, now we're ready to get down to some actual coding. Time to get your hands dirty. Let's switch to Flash, and you can see I've already drawn a star shape on the stage. Now I want this to be my particle, so I'll convert it to a symbol, name it star, and export it for ActionScript. And the class name is also star. I'll delete this instance on the stage, and the symbol is still in the library. And you can also see that I've already assigned a document class to this FLA file. Now I'm going to switch to Flash Develop to edit this document class. I've already written some code here, but these code this is just no more than like 3 variables and an empty method. So this is essentially just a skeleton. Alright, now I'm going to start coding for Stardust. Alright, first I'm going to create an emitter. Since I'm going to create a 2D particle effect, so I'm going to use an emitter 2D object. Emitter equals new emitter 2D, and I'm going to assign a steady clock to it with a steady rate of 0.5. Okay, now I'm going to add some initializers to the emitter. Add initializer. Since I'm going to use the star symbol as my particle, I'm going to use the display object class initializer to initialize the particles to have the visualization as to have the star shape as its visualization. Display object class, and I'm going to pass the star class reference to it. Next, I'm going to add a life initializer, and this life constructor requires another object, which is a random object. Here I'm going to use a uniform random. Oops, typo, uniform random. Alright, with a center of 50 and radius of 5. So this initializer will initialize new particle's life to a value between 45 and 55. This random value is generated by this uniform random object. Next, before that I'm going to first create a single point object. New single point. This single point object is actually a zone subclass object. And now I'm going to assign this to a position initializer. So new particle's position will be initialized to equal to the position of this point. New position. I'm going to pass in the point object. Okay. The last initializer is the velocity initializer. Oops, velocity. Okay. And this velocity initializer requires a zone object. I'm going to use a lazy sector zone with a radius of 10 and radius variation of 3. Okay, the velocity initializer would grab a random point in the zone object, and the position vector of this point would be assigned to the newly created particle's velocity vector. And a lazy sector zone with parameter 10 and 3 is actually a zone sandwiched between two circles with radii equal to 7 and 13. Okay, now let's add some actions to the emitter. So I'll write emitter dot add action. I want the particle's lives to decrease through time, so I'm going to add an age action. This will decrease each particle's life by 1 in each iteration of the main loop. And the next action is death life. This would mark a particle as dead if the particle's life reaches 0. And I'm going to add a move action. This would update the particle's position vector according to the particle's velocity vector. Okay, I think that's it. So far I'll need these 3 actions. Okay, now it's time for the renderer. I'm going to use a display object renderer. And the container I'm going to use for this renderer is the stage. So I'll just pass in this. And now add the emitter to the renderer. So I'll write emitter.add emitter. Renderer.add emitter. And start the main loop. And I'll use the add event listener. Enter frame event loop. This is my listener. And in this listener, I want to update the point's position to the mouse position and call the main loop, which is meter.step. Okay, now let's test the code. I'll test move by pressing Ctrl Enter. Okay, so now you can see the center of the emission is following my mouse, since the single point object's position is following my mouse. And this is, as you can see, the stars, I think they are traveling too fast, so I'm going to add another action. Use the damping action. Oops, not damping 3D, that's damping for 3D particles, just damping. And the damping factor, I think 0.1 is nice. Okay, so the particles will slow down as they travel. And the disappearance of a particle upon its death is kind of abrupt, so I'm going to add another new action. I want them to shrink to 0 scale when they die. So the action I'm going to use is scale curve with 0 growing time and 10 shrinking time. So this means at the last 10 units of their remaining life, the particles will shrink to 0 scale. Of course, you can set the scale curve action object to have other final scales, so you can make a particle grow to a scale of 200% when they die. But the default value of the final scale is 0, so the particle will shrink to 0 scale. Alright, so as you can see, that when the particle dies, they shrink to 0 scale. And there's another similar action to the scale curve action, which is the alpha curve. Oh, not alpha curve, sorry. Alpha curve, okay. And I want it to have a 20 growing time and 0 shrinking time. This means the particles would turn from totally transparent to totally opaque in the first 20 units of their life. Alright, let's test the movie. Okay, so now you can see the particles when they are first created, they are totally transparent, and after a certain amount of time they become completely opaque. Alright, so now you know the basic workflow of Stardust, and you can start creating your first Stardust application.